Hello students, welcome to my channel. Let's revise with Babita. So here we are again with the chapter solution. This is our module 6, right? We have already done, if you remember, in the last module we have done elevation and boiling point. But our next topic is depression or freezing point. Again, this is a colligative property. If you remember, colligative properties are those which depends upon the number of moles of solute, but not on the nature of solute, right? So before going to depression and freezing point, first point is, what do you mean by freezing point, right? So freezing point of a substance is the temperature at which the solid and the liquid form of the substance are in equilibrium. That means the solid and the liquid form of the substance have the same vapor pressure, right? So if we have, again the point is, अगर मेरे पास एक solvent है, एक solute है, and solute combines to give you solution, right? So अगर मेरे पास पानी का एक glass है, let us suppose that is my solvent, right? And it is denoted by T naught F. T naught F is the freezing point of a pure solvent. Let us suppose वो पानी है, ठीक है? And you all know that पानी का जो freezing point होता है, let us denote वो 0 degrees होता है, right? अब हमने non volatile solute add कर दिया. Let us suppose मैंने sugar add कर दिया. अब मैं आइसक्रीम बना रही हूँ, ठीक है? तो अगर मैं आइसक्रीम बना रही हूँ तो उसका टेम्परेचर जो है वो सपोज करते हैं वो -5 जाएगा, राइट? अगर हम सपोज कर रहे हैं इसका 0 डिग्री है, राइट? एंड इसका जो है वो हम सपोज करते हैं इट्स -5 डिग्री सेल्सियस, क्योंकि ऑब्वियसली जब हम आइसक्रीम बना रहे हैं उसमें बड़ा टाइम लगेगा, और अगर उसमें बहुत टाइम लगेगा तो इट्स -5 डिग्रीज. एंड -5 डिग्री सेल्सियस में इफ when we calculated -5 डिग्री जो है वो ज्यादा टाइम लगा रहा है, एंड यू नो 0 का वैल्यू ज्यादा होता है when you compare it with -5 degrees. So depression in freezing point जो है it is denoted by delta TF, right? And delta TF is equal to T naught F minus TF, that is freezing point 0 -5. 0 -5 वो आप क्या करोगे, that we will calculate depression in freezing point, क्योंकि 0 का वैल्यू बड़ा होता है as comparison to -5 वैल्यू में, टेम्परेचर में 0 बड़ा होता है, एंड बर्फ जहाँ पे बर्फ पड़ी होती है, मौसम बहुत ठंडा होता है, तो उसका फ्रीजिंग पॉइंट या जमने में काफी टाइम लगता है. बट व्हेन वी हैव टू कैलकुलेट इट, तो हमारे पास जो फॉर्मूला है दैट इज डेल्टा टीएफ, एंड यू नो डेल्टा टीएफ इज डिप्रेशन इन फ्रीजिंग पॉइंट. डिप्रेशन इन फ्रीजिंग पॉइंट इज डिनोटेड बाय डेल्टा टीएफ. डेल्टा टीएफ इज इक्वल टू टी नॉट एफ माइनस टीएफ, राइट? सो this is the definition for depression and freezing point. We can say it is the difference in the freezing point of solution, pure solvent, and the freezing point of solution, right? Depression and freezing point is the difference between the freezing point of pure solvent and the freezing point of solution, right? So, as observed experimentally, delta TF is directly proportional to M, and you know M is molality, that is calculated experimentally. So, if delta TF is directly proportional to M, delta TF is equal to KF into M. If M is equal to 1, it's molality, it's molar, then delta TF is equal. KF is a constant known as molar depression constant, right? Or gyroscopic constant. This is gyroscopic constant. The units of KF is Kelvin, kilogram per mole, right? So now the topic is molar depression constant. क्या होता है? Molar depression constant may be defined as the depression of freezing point when the molality of the solution is unity, right? So how you can calculate KF? KF is equal to MA RTF square upon 1000 into delta H fusion, right? Here MA is the molecular mass of solvent, right? R is a gas constant. TF is the freezing point of solvent. This is 1000 for the formula. And delta H fusion is enthalpy of fusion, right? And now we have to calculate a very important question. Determination of molar mass of solute from depression in freezing point. As we have done rightly that delta TF is equal to KF into M, right? And you know M is molality. Again the question is depression in freezing point a colligative property? Yes, it's a colligative property because it depends upon molality, and you know molality depends upon number of moles. Hence, it's a colligative property. Now, you know molality is calculated by using the formula number of moles divided by weight in grams of solvent into 1000, right? And you also know number of moles is calculated by using this formula, weight in grams upon molecular mass. Now substitute this value in equation first, right? When you put the value in equation first, what's the relation we get is delta TF is equal to KF into WB into 1000 upon MB into WA. Cross multiplication, delta TF into MB into WA is equal to KF into WB into 1000, right? And what the question is determination of molar mass of solute. And here you know MB is a molar mass. So MB is equal to KF into WB into 1000 upon delta TF into WA, right? It is similar as that of elevation and boiling point when we were calculating determination of molar mass of solute from elevation and boiling point. Only the difference is that we are writing delta TB and instead of KF we were writing KB. Otherwise the questions are same, right? So here you know KF is a constant, kaleidoscopic constant or molar depression constant. WB is weight in grams of solute, right? Delta TF is depression in freezing point and WA is weight in grams of solvent. Hope you will solve the numerical, right? And the last colligative property is our osmotic pressure. Before going to osmotic pressure, we have to do osmosis. Osmosis क्या होता है? हम क्या बोलते हैं osmosis का क्या मतलब होता है? The process of flowing of solvent into the solution through a semi-permeable membrane is known as osmosis, right? Osmosis जाने से पहले point आता है semi-permeable membrane क्या होता है, right? So semi-permeable membrane is a membrane which allows the solvent molecules to pass through but not the solute particle. जो solute को नहीं जाने देता, सिर्फ solvent उसमें से pass होता है. जैसे for example अगर मैंने चाय बनाई है, चाय को मैं छानती हूँ, चाय जो है लिक्विड जो है वो बाहर आ जाएगा, लेकिन जो चाय की पत्ती है वो ऊपर ही रह जाएगी. That is, it is acting like a semi-permeable membrane. So what is osmosis? देखो ये खाली पानी है यहाँ से, this is solvent, right? ये इस साइड से solution है, this is a U-shaped tube. यहाँ से खाली पानी, यहाँ से पानी plus sugar और पानी plus नमक, that's an aqueous solution, right? So ये पानी धीरे 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 इसमें जा रहा है, flowing of solvent into the solution, लेकिन किसके through? Through a semi-permeable membrane. Have you noticed कि इसका level जो है वो बढ़ गया, पहले ये same था लेकिन अब इसका level धीरे धीरे बढ़ गया. So जब पानी solution में जा रहा है, किसके through जा रहा है? Through a semi-permeable membrane, that is known as osmosis. क्योंकि अगर हम इसको रोकेंगे ही नहीं, एक टाइम ऐसा आएगा कि ये खाली हो जाएगा, right? So in order to stop the osmosis, we apply some pressure, and that pressure is known as osmotic pressure, right? So our question is, before going to osmotic pressure, we have two types of osmosis. One is exo-osmosis and another is endo-osmosis. Now, exo-osmosis means when the membrane permits the solvent molecules to come out through the membrane. It is called exo-osmosis, right? I'm repeating, when the membrane permits the solvent molecules to come out through the membrane, it is called exo-osmosis, right? And the other example is, another type is endo-osmosis. When the membrane permits the solvent molecule to enter inside it It is called Endo Osmosis, right? अब आप एक एक्सपेरिमेंट कर सकते हो घर में बैठ के. Just boil 2 eggs, right? जब आप दोनों अंडों को बॉईल करोगे, फिर you put 1 egg, उसका छिलका उतार के, you put 1 egg in a glass of water and another egg in sodium chloride. That means नमक वाले पानी में. What you notice, you just find out yourself, and then only you can define exosmosis and endoosmosis. Or similarly, if we put grapes, angur, in a concentrated solution of sodium chloride, that is namak wala pani, the grapes shrink. But if we put kishmish or grapes into pure water, they swell. That means एक वो absorb करता है और एक absorb नहीं करता है. That is exosmosis and endoosmosis. Try yourself, right? Now, question is, what is osmotic pressure, right? Osmotic pressure is denoted by pi, right? The pressure which is used to stop the osmosis is known as osmotic pressure. For example, अगर नलके में से पानी आ रहा है, right? हम क्या करते हैं, हम उस नलके को बंद करते हैं कि जो फ्लो पानी का आ रहा है वो रुक जाए. That is to stop it. So जो प्रेशर हमने यूज किया उसको रोकने के लिए, that is known as osmotic pressure. The pressure which is used to stop the osmosis is known as osmotic pressure, right? But अगर हम नलका बंद हो गया, पानी का नलका, फिर भी हम उसको जोर से बंद कर रहे हैं, फिर से हिला रहे, तो what happens? वो नलका जो है वो फ्री हो जाएगा, और जब नलका फ्री हो जाएगा तो वहां पानी आना शुरू हो जाएगा फिर से. That means the condition become reverse, right? So that is known as a reverse osmosis. If the pressure is more than the osmotic pressure, अगर प्रेशर ज्यादा हुआ किससे, then the osmotic pressure, the condition become reverse. It is known as reverse osmosis, right? So we have a very very important question जो आप खुद भी कर सकते हो. Give the point of difference between osmotic pressure, give the point of difference between osmosis and diffusion, right? As we have already done, what is diffusion? Diffusion means flowing of process of mixing of two or more than two components is known as diffusion, right? And osmosis जो है वो क्या होता है? Osmosis means flowing of solvent into the solution through a semi-permeable membrane, right? So 4-5 point of differences आ जाएंगे between diffusion and osmosis. So you try yourself, right? And now, based on osmotic pressure, we have 3 types of solutions, right? One is hypertonic solution, another is hypertonic solution, and third is isotonic solution. Two solutions having the same osmotic pressure is known as isotonic solution, or it is also known as isomotic solution, right? जिसका ज्यादा होगा, right, उसको क्या बोलते हैं? हाइपरटॉनिक सॉल्यूशन. और जिसका कम होगा उसको क्या बोलते हैं? हाइपोटोनिक सॉल्यूशन. जिसका सेम होगा, then it is known as isotonic solution. Now again the question is determination of molar mass of solute from osmotic pressure. You know, according to osmotic pressure, this pi is equal to CRT, right? You know, ideal gas equation is PV is equal to nRT, P is equal to N by VRT. N by V means concentration, right? So pi is equal to CRT, or you can write pi is equal to MB upon V into R into T. Pi is equal to MB, वही फिर से फॉर्मूला आएगा, number of moles weight in grams upon molecular mass into 1 upon V into R into T, right? This is pi. This can be used to calculate osmotic pressure. Now, cross multiplication, MB into pi into V is equal to WB into R into T. And we have to calculate molar mass. So, molar mass MB is equal to WB into R into T upon pi into V. This formula gives you the molecular mass of solute from osmotic pressure, right? Here you know MB is molecular mass of solute, WB, it's clear, weight in grams of solute, R is a gas constant, T is the temperature, V is the volume, and pi is osmotic pressure, right? So this we have done all the colligative properties. That is, 4 colligative properties are there: relative loading in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. I hope you all are solving the numericals based on these colligative properties. Thank you. Be safe.